Hello, hello. This is Team Pi from RC 1301 KLAIT Hubli. In this, we are trying to give some basic concepts of the operators in C language. What we are discussing in this particular session is we try to explain about the definition of the operators and what are the different operators which will come across in any programming languages. We specifically highlight on unary, binary and ternary operators. And apart from this, we try to make the different categories of the operators available in any of the programming languages. Specifically here, we are highlighting on arithmetic, relational, logical and bitwise operators as a categories. And at the final, we are trying to give a sample example for the evaluation of the students which uses all these four types of the operators, and the student has to get the answer for it. First, we will try to see what are the operators. An operator is a symbol that tells us the compiler to perform the specific mathematical or logical functions. So when we try to compute something, we need some of the operators so that that computations happens. Simple example is C is equal to A plus B, or what is the value of addition of 10 plus or 10 and 20, that is 10 plus 20, we try to say it as a 30, and these are used for the computations and solves the many solutions, complex solutions, maybe in a different fields, maybe a simple applications to the complex research works wherein which it involves a lot of the calculations. So we'll try to briefly define about what are the different types of operators we will come across. There are different operators like unary operator, the operator which works on the single value or the variable. That means example is not A. Here A is a variable. So in this case, unary not A, if A is having the value true, then it becomes a false. If it is having a false, then it becomes a true. Binary operators, the operation on two values are the variables. That is, here we have taken a simple example of C is equal to A mod B. Here modulus or the remainder of the division of the two numbers. A is a divider, it is the dividend, and B is a divider, and the C will be having the remainder value, whatever the remainder we get after dividing A and B. Ternary operations uses the three arguments. That is, here we have A, B and C as an arguments, or rather A and B. It tries to compare if A greater than B, then value is equal to 100 or it is equal to 200. That means A is less than or equal to B, then it will be having the value equal to 200. So these are some of the operations or the operators which are available depending on how many arguments. The first one is unary operator takes only one argument, binary takes two arguments, and ternary takes three arguments. So we can make the different categories as some of the operators are supportive for the arithmetic and some of the operators are used for the comparison or maybe assignments, etc. We are calling them as the relational, means they are trying to establish the relation between the two variables or the two values. The logical operations may be something like or, and, or not, something like this. So that is, we have come across these things in a different fields. So similar way, these operators are used in case of the C language. Bitwise, that means each value of a variable is assigned, or it has been stored in the memory as a bits, binary bits. So if you want to apply, or if you want to do some manipulation with the bitwise of that value, then we can use these operators. An arithmetic operator is a mathematical function that takes the two operands and performs the calculation on them. So we have the different operators in the arithmetic operator, that is addition, we denote it by plus, subtraction, we denote it by minus, multiplication instead of x. To remove the confusion of X alphabet, here in computers it is used as star. Division, instead of the horizontal and two dots, one above and down, we are trying to use a slash as the division, and the modulus is a percentage operation, or the percentage symbol which we are using normally. And we have the couple of other operators, that is auto increment and auto decrement. That is, if you try to use these things, then the value is automatically incremented or decremented by 1. So here we will try to take some example on this. If A is having the value 10, B is having the value 20, sorry, I repeat it once again. If A is having the value 20 and B is having the value 10, then the addition of A plus B, represented as C is equal to A plus B, the resultant is stored in C over here, and addition of A and B is equal to 30. And similarly, subtraction, A minus B, I will be having it as 10. A multiplied with B, it is 200. Division, A divided by B is 2. See, A mod B, that is a remainder of dividend with the divisor, that is B. 20 divided by 10, I get the answer is equal to 2, and remainder is going to be 0. So the C is having the value equal to 0. Auto increment, if I try to increment that is A plus plus, will try to give me 21. It automatically increments the value by 1. C is equal to A minus minus. This is auto decrement example. Here value is decremented by 1, that it becomes 19. The second category we are trying to highlight here is the relational operator. Is a programming language constructor operator that tests or defines some kind of a relation between the two entities, whether it is equal, not equal, greater than, or lesser than, and even we can go with greater than or equal to, less than or equal to, something like this. So some of the examples here: if A is equal to 20, B is equal to 10, these are the variables which are holding these values. Equality A double equal to B, it is not true. Any conditional concepts in C or in any language will return not true. That means it is false. Not equal, that is, I can use A not equal to B. This is definitely true because A is having a value 20, B is holding the value 10. 20 value is not equal to 10. So this expression is equal to true. Greater than A, greater than B. Here I am sorry, this has been printed as a B, small b here. It is a true because A is having the value 20, B is having the value 10. Less than A, less than B is not true because A is holding the value 20, B is holding the value 10. So B is not greater than A, so it is not true. Greater than or equal to is also not true. Lesser than or equal to is B is not true. Whether here everything is correct. You just observe this, greater than or equal to, that is A greater than or equal to, yes, that means A, either it is greater than B or A is equal to B. This answer should be equal to true. It is this, whatever the thing has been written over here, purposefully written over here, is not correct. So we need to say that here it is a false. That means this answer is false and the correct answer is it is true. Logical operators. Logical operators defines the evaluation on the result of two logical results. There are three operators have been defined here. The logical AND, logical OR and logical NOT. These operations are demonstrated here in the example. If A holds 1, B holds 0, then A and B is false, A or B is true, not A is false because A is holding 1, so it becomes false, not B equal to true because B is having the value 0, negation of or not of B, that is not of B is 0, that means it is 0, so it becomes true, and not of A and B is what? It is equal to true. Similarly, we have the last category as the bitwise operators, which works on the bits of the operators. We have bitwise AND, OR, XOR, right, shift right and shift left. We have example, A is equal to 6, B is equal to 8. Bits have been represented over here. A bitwise AND. If you try to AND up these two things, then I am going to have a 1 in this place because this fourth bit and rather 3 bits of the B are 0 and the fourth bit of A is 1. So I will be having the answer is equal to 0. But in case of A, or that is A or B, I will be having all the last 4 bits equal to 1. So the value is 15. Similarly, XOR, if the XOR operation, I will be having 15, and A shift 1, you just try to see, I am trying to shift this A by 1, so it becomes 1 1 1 0, so I will be having the value is equal to 14. Similarly, B right shift 1, it becomes this 1 is shifted to this place and rest all things remain zeros, so I will be having the value is equal to 4. If you observe over here, by shifting one bit, I can achieve left shift, achieves multiplication by 2, right shift achieves the division by 1. So at last, we'll try to see what is the operation or what is the evaluation of this. If A is having 8 and B is equal to 6, try out yourself. C is assignment, C equal to is an assignment, A cross B is the arithmetic operator, ampersand is logical, and here the bitwise OR, and here a shifting, we have incorporated all these operators and try to verify the answer for the values 8 and 6. You should be able to get something like 4. If wrong, then verify your evaluation. Thank you. Thanks a lot.